Hello Honors Pre-Calculus students, this is Mr. Cruzado, and the goal today is to review the unit circle which you talked about last year in Algebra 2. I'm going to do some review problems. You can pause the screen at any point and try the problems before you listen to my explanation. I'm also going to explain how I learned it in high school, and at the end of the video I'll talk about a way that you may have learned it or studied the unit circle. So the first question here, I just want to quickly review converting to radians and degrees. So we all should know that pi over 180 is really the number 1. Same thing with 180 degrees over pi. This fraction, those two fractions I wrote are just really 1. So in problem number 1, if you want to convert to radians, or excuse me, the radians to degrees, I'm going to multiply by 180 degrees over pi. So the 6 goes in the 180 30 times, so it's 7 times 30, which is 210 degrees. A while back, one of my students talked about 7 pi over 6. He said he thinks of this as 7 times pi over 6. So he thinks of it as 7 30 degrees because he knows pi over 6 is 30 degrees. So 210 degrees. Likewise, if he saw, say, 5 pi over 3, that student said he thinks of this as 5 times pi over 3. And he said, well, that's 5 60s, so 300. So that's one way that my student in the past has converted. Problem number 2, if you want to convert here, you're going to multiply by pi over 180. That becomes 12 pi over 18. And you want to reduce that, you could reduce by 6, so 2 pi over 3. All right, on the unit circle, some of you I know memorized the unit circle, so some of you are familiar with this unit circle that I'm showing on the screen, and some of you have memorized it. I will post this on the website for your reference, and if you're a good memorizer, feel free to utilize this unit circle. Notice the symmetry here. If I were just to highlight 1/2 root 3 over 2, then here in green we have negative 1/2 root 3 over 2. Reflect again, we got the negative 1/2 negative root 3 over 2, and reflect again, we have 1/2 negative root 3 over 2. Okay. The way I learned it in high school, though, was a little bit different. I always drew the triangle. So if I were to look at problem number 1, and I do this in my head at this point, so pi over 4 I know is 45 degrees, so here's pi over 4. I draw the circle in my mind. The hypotenuse is 1 since we're talking about the unit circle. The legs from geometry are root 2 over root 2. The sign, remember, refers to the y value, so I'm going to write this over here in the margin, that the sign of the angle refers to the y value in the unit circle. So the y value is going to be root 2 over 2. So from geometry, you should remember in a 45, 45, 90, you had x, x, x root 2. And in the unit circle, I tend to use this triangle for 45, 45, 90s. 1, root 2 over 2, root 2 over 2. For problem number 4 here, negative pi over 2. So negative pi over 2 brings you down here. That ordered pair is 0, negative 1. The sign refers to the y value. So here the y value is negative 1. Again, if you want to pause the screen, try these problems, and then watch the video. Okay, cosine. The cosine of theta is equal to the x-coordinate in the unit circle. So I'm writing this off in the margin. So when I see cosine of 5 pi over 3, that's 5 pi over 3s, or 300 degrees. So I know I am in quadrant 4. So I draw this little picture, drop the altitude. I know the reference angle is pi over 3, because there's 2 pi radians in a circle. I labeled my hypotenuse 1. Pi over 3 is the same as 60 degrees. So I know this side is 1/2, and this is √3/2. So I'm going to draw the 30, 60, 90 here that you learned in geometry. So when you have a 30, 60 degrees, you learn that the hypotenuse was 2x, across from the 30 was x, and across from the 60 was x√3. So when I have 30, 60, 90s, I have 30 degrees, 60 degrees. I label the hypotenuse 1 across from the 30 as 1/2. That's always the shorter side, and the long side is √3/2. So looking at number 5 then, the cosine refers to the x value. So the x value here, if I were to label this point, is 1/2 negative √3/2. So the cosine of 5π/3 is 1/2. Problem number 6, 3π/2 is a positive angle and brings you around to here. Again, that ordered pair, just like problem number 4, is 0, -1. And cosine refers to the x value, so the cosine of 3π/2 is 0. Okay, problem 7 and 8. Again, I draw a picture in my mind. Tangent of 2π/3, that's 2π/3s, or 120 degrees. So I think about a 120 degree angle. So here's 2π/3. The reference angle is π/3. I again drop the altitude. I label the triangle, hypotenuse 1. Π/3 is the 60 degrees, so the horizontal is 1/2, and that's √3/2. So the ordered pair is -1/2, √3/2, and I showed you that unit circle. If you're a great memorizer, that's perfectly fine. Off to the margin, I'm going to write in the unit circle, the definition of tangent is the y-coordinate over the x-coordinate. You also could use opposite over adjacent. Just be careful you don't forget the negative. So the tangent of 2π/3 is the y-coordinate, which is √3/2, divided by the x-coordinate, which is -1/2. The 1/2s reduce, or the 2's reduce out, so you get -√3. If you wanted to use the opposite, which I'm highlighting in green, divided by the adjacent, which is the 1/2, just make sure you include the -1/2 because the x-coordinate is going to the left. Tangent of 9π/2. Well, this is equal to the tangent of 4.5 pi. So what does that mean? So a complete circle is 2 pi. Here's 4 pi, and then you're moving to the point up at the top where the blue dot is. That's 0, 1. The tangent is the y-coordinate over the x-coordinate, and you cannot divide by 0, so don't leave the answer like that. We say the tangent of 9π/2 is undefined. So this page here was meant to do the sine, cosine, and tangent. You should have also learned the reciprocal functions last year. So here, cosecant of 5π/6, I'm going to write off in the margin for the unit circle. The cosecant of a theta is 1/y. So when I see this problem, I think of this as 1/the sine of 5π/6. So me personally, I figure out the sine of 5π/6, and then I take the reciprocal for the answer. So 5π/6 is 5π/6s, so 5/30s, so 150 degrees. So here's the angle, 5π/6. The little reference angle, this little angle that goes to the x-axis, is π/6. Again, I'm going to drop the altitude, label the hypotenuse 1. across from the 30 degrees, which is the pi over 6, is 1/2, and that's root 3 over 2. The sine of 5 pi over 6 refers to the y value, so that's 1/2. Therefore, the cosecant of 5 pi over 6 is 1 over 1/2, which is equal to 2. Again, just for clarity, I tend not to write this down here in yellow because I know the cosecant is the reciprocal of the sine. Okay, problem number 10, cosecant of pi. So pi puts you on the axis here with this green dot. That is -1, 0. So the cosecant is 1 over y, so 1 over 0. And we don't leave it like that, so we say the cosecant of pi is undefined. Okay. Problem number 11. Again, I'm going to write off in the margin. The secant of theta is 1 over the x value in the unit circle. So when I look at this problem, I think of this as the cosine of 5 pi over 6. And I know I just drew the picture in the previous problem, but I'm going to draw it again. So we have 5 pi over 6. I drop the altitude. Reference angle is pi over 6. I label the triangle 1, 1/2, root 3 over 2. The cosine refers to the x-coordinate. So the x-coordinate is root 3 over 2. But the secant is the reciprocal. So, and the other thing you don't want to forget is this is a negative x-coordinate. So this ordered pair is negative root 3 over 2, 1/2. So make sure you include that negative. So the reciprocal is going to be -2 over root 3. We're going to rationalize, so root 3 over root 3, which is -2 root 3 over 3. If it said, for instance, the secant of 7 pi over 6. The secant of 7 pi over 6 is the same picture, but reflected. So hopefully you realize the symmetry here. So if it said secant of 7 pi over 6, it's really the same picture. So the secant of 7 pi over 6 is still the x-coordinate. So this is going to be the same answer. So -2 root 3 over 3. Okay, problem number 12. And I purposely put the odds to be in the quadrants and the evens to be on the axes. So -pi over 2 brings you down here. That ordered pair is 0, -1. Secant is 1 over the x, so that's 1 over 0 again. So we say the secant of -pi over 2 is undefined. If it said the secant of pi, well, the secant of pi would be the red dot, which is -1, 0. So this would be 1 over -1, which is -1. Let's take a look at the last two examples. The cotangent, so I'm going to write this in the margin again. The cotangent is a reciprocal of tangent. So the cotangent is to find the x over the y coordinate. And I want to make sure that you remember those definitions. So when I look at problem number 13, again I draw a picture. So a negative angle goes clockwise. This is going to be pi, so we'll end up here. So this is -7 pi over 6. I'm going to drop the altitude. The reference angle is pi over 6 again. 1, 1/2, root 3 over 2. For those of you that like to label the ordered pair, -√3 over 2, 1/2. The cotangent is defined to be the x-coordinate over the y-coordinate. So the x-coordinate is negative root 3 over 2 divided by 1/2. So we get negative root 3. Before we take a look at number 14, let's do an extra problem here. Cotangent of 5 pi over 4. So 5 pi over 4 would bring you into quadrant 3. The reference angle is pi over 4. Again, I like to drop the altitude. 1 root 2 over 2, root 2 over 2. The coordinate is negative root 2 over 2, negative root 2 over 2. So the cotangent is the x over the y, and hopefully you realize those values are the same, so this is positive 1. Okay, number 14, the cotangent of negative 3 pi. So negative 3 pi is going around the circle, that's negative 2 pi, and then you would end up there. That coordinate is negative 1, 0. The cotangent is the x-coordinate over the y-coordinate, so negative 1 over 0. Again, we're going to say the cotangent of negative 3 pi is undefined. If it's the cotangent of pi over 2, well, pi over 2 is the red dot, which is 0, 1. So the cotangent of pi over 2 is 0 over 1, which is 0. So I hope you found this video useful on reviewing the unit circle. We're going to post some information on the website for you to practice.